Hello everybody, welcome to Guidance Education channel. We will see the topic that is discussed in this video. In this video, we are continuing class 11 chemistry, classification of elements and periodicity of properties. Under that, modern periodic table and subtopic periodic properties part 1. We will do introduction, atomic radius definition and limitation in assessing atomic radius. This video will be of great use to you, so watch it completely without skipping. And if you think the video is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us start the class right away. Periodic properties of elements part 1. Periodic properties of elements is otherwise known as atomic properties. We have already seen that the properties of elements repeat at regular intervals, that is why it is called periodic properties. Atomic properties can be discussed under two headings, that is properties of individual atoms and properties of groups of atoms. Properties of individual atoms means isolated atoms, that is atoms that are separated and exist individually. Individual atoms have a set of properties. Please remember, in nature, atoms do not exist individually or isolated condition, but they remain in groups. Matter exists in the form of groups of molecules, and when they remain in groups, they exhibit another set of properties. We will just list out first the properties of individual atoms. First and foremost, atomic radius. By atomic radius, we mean the size of the atom. Second one, ionic radius. Some elements have the tendency to lose electrons and become cations, that is positively charged ions, whereas some other elements have the tendency to accept electrons and become anions, that is negatively charged ions. The size of the cation or the anion, as the case may be, will be different from the size of the atom of the element. That is, the radius of the cation and anion will be different from the radius of the corresponding atom. Ionic radius means size of the ion. The third one is ionization enthalpy. Ionization enthalpy is the energy change accompanying the loss of an electron. It is the energy absorbed by an atom when an electron is lost from the atom, that is, during the formation of cation. Why should atoms lose electrons? We will answer that question in the coming videos. Fourth one, electron gain enthalpy. It is the energy change when an atom accepts electron and becomes an anion. Again, why should an atom accept electron? That question also we will be answering later on. Anyway, when electron is accepted by an atom, it loses some energy while becoming an anion. Fifth one, electronegativity. It is the measure of the capacity of an element to attract towards itself the shared pair of electrons in a covalent bond. Sixth one, valence or oxidation state. It is the charge acquired by an atom of an element while forming a compound with other atoms of other elements. For example, in hydrogen chloride, the oxidation state of chlorine is -1. Put the sign, that is negative sign first and then the number. And that of hydrogen is +1. While representing, you have to put the sign first and then the number, whether it is positive or negative. When sodium combines with chlorine to form sodium chloride, sodium loses one electron and becomes positively charged. The charge on the sodium atom will be 1 positive and the charge on the chlorine atom will be 1 negative. So when we are representing the charge on the cation or the anion, we have to put the number first and then the sign. But when we refer to the oxidation state, for example, sodium has oxidation state +1 and chlorine has oxidation state -1. Valency is the combining capacity of an element. The combining capacity of hydrogen is 1 and that of chlorine is also 1. Even though the magnitude of the charge and the valence as well as the valency may be the same. In the case of valency, the sign, that is, the sign of the charge is not represented. It is only a number. In magnesium chloride, we write it as MgCl2 because though the valency of chlorine is 1, the valency of magnesium is 2. So they are interchanged while writing the formula. Please make a note of that. All these properties we will be discussing in detail. In this video, I will give the definition and difficulties in determining atomic radius. But before that, we will also see the properties of groups of atoms. Groups of atoms mean groups of molecules. Groups of molecules form particles that constitute matter. Okay, the first property, melting point, that is, the temperature at which the substance melts, that is, the solid gets converted to liquid. Second one, boiling point, which is the temperature at which the liquid starts boiling and gets converted to vapor state. Third one, heat of fusion. What is heat of fusion? It is the amount of energy absorbed by the solid substance at melting point till all the substance is converted to liquid state. Next one, heat of vaporization. It is the amount of energy absorbed by the substance at its boiling point till all the substance gets converted to vapor state. Fifth one, energy of atomization. It is the energy required to isolate atoms from groups of atoms, that is groups of molecules. Sixth one, density, and seventh one, atomic volume. We will be concentrating only on properties of individual atoms. We will take up the first one, atomic radius. Atomic radius is usually measured in picometer or in angstrom because the value is very small. Atomic radius is the distance from the center of the nucleus to the outermost shell which contains electrons. I will explain that. Let us consider a case. This is the nucleus with its center, then shell number 1, shell number 2, and then the outermost shell. I have shown only the outermost shell complete. Valence electrons are present there. This distance from the center of the nucleus to the outermost shell which contains the electron is the atomic radius. It can also be defined as the distance from the center of the nucleus to the point up to which the electron cloud, that is, the probability of finding electron, is maximum. Both the definitions mean the same. The outermost shell that is shown in the diagram is really the electron cloud. The boundary is not sharp as is shown here. Usually, we represent this electron cloud as a line, a circle in the boundary diagram. Estimating the atomic radius is not an easy job. There are some limitations or difficulties in estimating the same. We will see one by one. Atomic boundary is not very sharp. Though we represent the electron cloud or the boundary as a circle in boundary diagram, electrons may sometimes cross this boundary and move beyond this boundary or this maximum density area. Second one, difficulty to separate a single atom. In a substance, atoms remain as molecules and molecules form groups. The presence of other atoms around an atom affects the radius of an atom. And lastly, atomic radius of the same element changes when the bond type changes. That is, one and the same element may form covalent bond or ionic bond in different compounds. Then the atomic radius of that atom will not be constant, it will change. For example, in hydrogen chloride, chlorine forms a covalent bond with hydrogen. Whereas in sodium chloride, chlorine forms an ionic bond with sodium. The atomic radius of chlorine in these two cases will not be the same, it will be different. In spite of these difficulties, scientists have found out some practical methods by which the atomic radius can be determined or assessed. We will continue this topic in the next video. Otherwise, this video will be very long. Thanks for watching and please subscribe. We will meet in the next video. Till then, bye. Take care.